Today we're going to continue learning about trig functions, and we're going to specifically look at the unit circle today. This is also a fairly long note sheet with quite a bit of info on it, so I'm only going to go over the first couple of pages. Before I start, I want to point out a couple of previous concepts that are going to be relevant for this lesson. And that's the special right triangles that you learned back in geometry. So you need to know about 45, 45, 90 and 30, 60, 90 triangles. This page right here is the warm-up that's posted to my website. So I'm going to go through it while I go through the notes, but if you want extra notes, then check this out. It's posted on my website with all of the additional descriptions and also a couple examples at the bottom. But as far as the notes go, I'll make sure I cover that throughout the note sheet. So for the warm-up, exercises 1 and 2, you need to write the degree measure in radians and the radian measure in degrees. I'm just going to go through these. You can watch as I go through them, but I think at this point everyone should know how to do this, so I'm not going to explain. Same thing with 3 and 4, finding the reference angle. Okay, so now that we've gone over the warm-up, hopefully you followed along as I went through those. We're gonna start looking at the exact values of trig functions using the unit circle. So here you see that it says you can find the exact value of cosine and sine for the angles that are multiples of 30 or 45. To add a little note in here, if triangles are or angles are multiples of 30 or 45, that means you're dealing with 45, 45, 90. Oops. So 45, 45, 90 triangles or 30, 60, 90 triangles. It says we will use these cosine and sine values to find exact values for the remaining trig functions. And this is just a review of what we've been doing for the last couple of days. So if P is a point on the unit circle, recall that the radius of the unit circle is always 1. Then technically you have cosine, which is x over r. But if r is just 1, then you can really just say that it's equal to x. If you had x over 1, that's just equal to x, which is why you see the original part saying that cosine of theta is equal to x. Sine of theta is equal to y. Again, technically it's y over r. R is 1, so just y. Tangent is y over x. Cosecant is 1 over y. That would, in the past, be r over y. R is equal to 1, so we're just going to say 1 over y. Secant is 1 over x, and cotangent is x over y. These are just the values that we've been working with. But now we're going to start using our 30, 60, 90, and 45, 45, 90 triangles. So again, if you are feeling like you're missing some info on these, go back to that warm-up sheet that I started talking about. There's a lot more notes on these triangles on that warm-up if you're interested. Before I start, I need to talk about the quadrants. So we have quadrant 1, and in quadrant 1, your x-coordinate and your y-coordinate are positive. In quadrant 2, you have a negative x-coordinate and a positive y-coordinate. In quadrant 3, you have a negative x and a negative y coordinate. And in quadrant 4, you have a positive x and a negative y coordinate. So you need to make sure the signs correspond to the quadrant. Your answers are always going to come out positive, but you have to determine where the point is that you're working with and match it to the correct quadrant. Make sure you have the correct signs. You'll see when I go through the example what I'm talking about there, but this is important to know. Looking at the first example, we're trying to find the cosine and sine values. That's all we're looking for here, cosine and sine values of each angle. We're going to start with the angle 60. So I'm going to draw this angle 60 on my coordinate plane, which, by the way, this is just the unit circle. I already have it drawn in for you. So I have my initial side. My terminal side is located at 60 degrees. Okay, so if that's located at 60 degrees, we know that the radius is 1. We know this length here is equal to 1, but we don't know anything else in order to find the x and y value. So when I say x and y value, I'm talking about this point that intersects at the unit circle. We're looking for x and y, but we don't have any other info to do that. So what I'm going to do is I'm going to drop a line down to the x-axis, a perpendicular line to the x-axis, so forming a right angle, and also forming a 30 degree, 60 degree, and 90 degree angle. So this here is a 30, 60, 90 triangle. And just to refresh your memory on the formulas that we're going to be using, in a 30, 60, 90 triangle, the hypotenuse is equal to 2 times the short leg, and the longer leg is equal to the short leg times the square root of 3. So we're going to use the triangle, we're going to use this triangle, and we're going to find our value of x and y, which is going to be our sine and cosine value. I'm going to redraw this triangle just so we can clearly see it. I'm also going to label the sides for you. So the hypotenuse is always the diagonal. The short side is literally the short side of the triangle, but it's also always across from the smaller angle. And then the long side is your last leg. So if we know the length of the hypotenuse, then we're going to start with that. Okay, you start with whatever you know. We know the hypotenuse, we're starting with the hypotenuse. Knowing that the hypotenuse is 1, we can substitute 1 in for that value, and we have 2 times the short leg. I'm going to label the short leg x because up here, the short leg is on the x-axis. So 2 times x. In order to solve for x, I divide both sides by 2, and x is equal to 1/2. Here's your x value. I'm going to label the long leg y because this leg right here runs parallel with the y-axis. If I know that x is equal to 1/2, or I know that the short side is equal to 1/2, I'm going to substitute in my value of x for the short side. Long leg is y, which is equal to my short side, which I just solved and is equal to 1/2, and then the formula says multiplied by the square root of 3. So this ends up simplifying to y equals the square root of 3 over 2. And there's your y value. So no matter what the problem is that you're working on, your x and y value are always going to end up being positive numbers like they are here. But then you have to identify where your point is. And okay, this point right here is in quadrant 1. Quadrant 1 indicates that both your x and y values are positive, so that's it. We don't need to change our signs. But sometimes you will have to, like the second example I'm going to go over. Also, once we find these points, once we know that x is 1/2, and once we know that y is square root of 3 over 2, I can rewrite this ordered pair, and I can write that as the point 1/2, comma, square root of 3 over 2. All right, my x value is how far we went over on the x-axis. My y value is how far we went up on the y-axis, and those two values correspond to your x and y, or your short and long legs. So now that we have this info, we're looking to find cosine of theta, which recall cosine is x over r, or x over 1 because r is 1, which is just your x value. So your cosine is your x value of 1/2. And sine of theta is y over r, or y over 1 for the radius. Simplify that to just your value of y, which in this example is the square root of 3 over 2. There's your sine and cosine value. And that's the answer for number 1. Okay, next we're going to look at the angle of 225 degrees. So same thing, we're looking to find our sine and cosine value of 225. So I'm going to start by sketching the coordinate plane. And I'm going to sketch 225 degrees, which lies 45 degrees past 180. I'm also just going to sketch the unit circle. and I'm going to mark where my point intersects the unit circle. So this is the point where we're looking for x comma y. All right, I don't know anything besides from the fact that the length of the radius is 1. So the 45-degree reference angle indicates I can draw a line back to the positive x-axis, and right there I just formed a 45, 45, 90 triangle. If I resketch it a little bit larger, we have our 45-degree reference angle, we have our 90-degree angle that we formed, and remember the interior angles of a triangle add up to 180, so what's left over is 45 degrees. Now in a 45, 45, 90 triangle, it's important to know that your legs are congruent, meaning they are equal. So it doesn't matter which one you label because they are both called the leg. This is called the hypotenuse, and the length of the hypotenuse is the only length we know, which is 1. I'm going to, just for the sake of explaining, label that part or this part of the triangle as x because it lies on the x-axis. And I'm going to label this part of the triangle y because that represents the distance traveling down on the y-axis. And now I can use my 45, 45, 90 triangles to solve for the missing side lengths, and which will add to or allow me to solve for the missing values of x and y. There's only one formula for the 45, 45, 90 because the hypotenuse is one length and then the legs are both the exact same length. So the only formula you need to know is a leg length times the square root of 2. Well, we already know the hypotenuse length, so that's where we're going to start. We're going to substitute 1 in for the hypotenuse, and this is equal to, we'll just use x, but you could use x or y, x times the square root of 2. If you solve for x, you're dividing both sides by the square root of 2. And just remember right here that you cannot have a square root in the denominator, so I need to multiply the numerator and the denominator by the square root of 2, giving me the square root of 2 over the square root of 4, which is 2. And that's equal to x. So recall that x and y are congruent, they are equal to each other. So if the square root of 2 over 2 is equal to x, then the square root of 2 over 2 is also equal to y. Now, before I can write my ordered pair, this point is in quadrant 3. If it's in quadrant 3, that means you have a negative x and a negative y coordinate. Your answers are always going to come out positive, but you have to make sure you apply the correct signs. So when I write this point, I need to write this point as my x coordinate of square root of 2 over 2, but that is now negative, and negative square root of 2 over 2 for my y coordinate. Recall that cosine of theta is x over r, or x over 1. In this case, the x value is the square root of 2 over 2. And sine of theta is equal to y over r, or y over 1, which is just y. So the square root of 2 over 2 is your sine value as well. There's a note right here that says using reference angles or quadrantal angles, you should now be able to find the trigonometric function values for all integer multiples of 30 degrees, which is pi over 6 radians, and 45 degrees, which is pi over 4 radians. These special values wrap around to produce 16 special points on the unit circle. Use what you know to complete the unit circle on the next page. So I'm going to start you off for the unit circle, and then that's actually where I'm going to end the video today because I want everyone to be able to solve the unit circle by yourself. So if you go to my note sheet on my website, you can find the answers to the unit circle. Obviously, I know you can do that, but it's important that you know how to do this by yourself, especially if you're planning on taking calculus next year. None of this is hard. It's extremely repetitive. You just need to make sure you know how to do it. So this is what the unit circle looks like, and there's key values within the unit circle. I'm going to start by talking about the key values in quadrant 1. And in quadrant 1, recall that you always have positive x and positive y values. So within each quadrant, you have special angles. I want you to find, not just me, but the unit circle in general, is finding the degree measure, that corresponds with the radian measure. So you should all know how to convert degrees to radians. You multiply by pi over 180. And then at each point, and when I say point, I'm talking about this point, you have your x and you have your y value, which coincidentally is your cosine and sine value without doing any other work. So within each point, or within each quadrant, you have 3 points. Each point has a degree, radian, an x and y, or more specifically, a cosine and sine value. All of the points on this unit circle are either 30, 60, 90, or 45, 45, 90 triangles. And then all of the quadrantal angles are angles that you already learned about last lesson. Quadrantal angles are multiples of 90. So think back to the last lesson. What is this point? Just give you a heads up on this one. This point is at 0, 1. And 90, if we convert that to radians, 90 converted to radians is pi over 2. If I was to ask you the cosine value of 90, cosine value of 90 is your x value, it's 0. If I was to ask you your sine value of 90, your sine value is 1. Okay, so besides quadrant 1, if we just label all of these here, quadrant 2. Quadrant 2 has negative x values, positive y values. Talking about quadrant 2, let's take a look at 150 degrees. So if I was to form a triangle with 150, I'm going to drop an angle right here. This forms my 90-degree angle. I also am going to indicate where my reference angle is, which is right there. This forms a 30-degree angle. What's left? 60 degrees. So I just formed a 30, 60, 90 triangle at 150, which you can all solve for, and that's the one I'm actually going to do. You can all solve for, which will give you your cosine and sine value. And you need to do this for the rest of them on the unit circle. So I'll come back to that, but while I'm talking, we're going to talk about quadrant 3, negative x, negative y. And lastly, quadrant 4, positive x value, negative y value. All right, let's do one of these. We're doing this one that I started. So we're doing 150 degrees. If I convert 150 to radians, multiply it by pi over 180, I know what this one is going to be. It's going to be 5 pi over 6 when you simplify that. All right, besides from your radian measure, we need to find where's this point. So what are your x and y values on that point? We're going to use a 30, 60, 90 triangle. I'm going to start with the fact that we know the hypotenuse is 1. Remember, we know that this value, this length, is always 1. So you're going to start with the hypotenuse. Hypotenuse is equal to the short leg times 2. And the short leg is across from the 30-degree angle. This short leg corresponds to the height on the y-axis. So I'm going to label the short leg as y. Substitute in the value of the hypotenuse, which is 1. The short leg, I'm using a variable y, times 2. Divide both sides by 2. Y is equal to 1/2. All right, so this value is 1/2. I'm going to label the last side, the long leg, as x. And recall that the long leg formula is equivalent to the short leg, which we just found, times the square root of 3. So the long leg is, we are representing the long leg with a variable x. This is equal to the short leg, which we just solved for, and that was 1/2, times the square root of 3. X is equal to the square root of 3 over 2. So now that we found the sides of our triangle, we're not quite done because we need to make sure we include the correct signs. So in quadrant 2, we have to make sure we include a negative x value. That tells me that my x value here is now going to be negative square root of 3 over 2. And quadrant 2 includes a positive y value, which is 1/2. So we just did the work. We know that 150 Sorry, just getting all that out of the way so we can talk about this. We know that 150 in degrees is equivalent to 5 pi over 6 in radians. And we also know that our sine value is our cosine value. Cosine value is negative square root of 3 over 2, and our sine value is 1/2. All right, cosine is x, sine is y. You can do this for every angle on the coordinate plane, and that's what I want you to do for the rest of this class. So fill in your unit circle. Please try not to just copy it down because it's not going to help you. Please make sure you actually try to figure out how to do these. Make sure you understand it. Check your answer against mine on my website. Again, it's imperative that you know how to complete the unit circle. Okay, and tomorrow we will finish this note sheet.